In this lecture, we study about differentiation under integral sign DUIS rule number 2, or it is called Leibniz rule. Let What is DUIS rule number 2? Let I of alpha, which is equal to integration of f of x alpha under the limit a to b, where a and b are functions of alpha, then di d alpha, which is equal to integration of derivative of derivative of f of x alpha with respect to alpha under the limit a to b with respect to x, plus f of b alpha, means functional value of f of x alpha at x equal to upper limit, into derivative of b with respect to alpha minus f of a alpha. It means the functional value of f of x alpha at x equal to lower limit a, into derivative of a with respect to alpha. This is called Leibniz rule number 2, or DUIS rule 2. Let us take one example to verify DUIS rule number 2. Verify the rule of differentiation under integral sign for the integration of log of x under the limit a to a square with respect to x. Now, this is very clear that if the limit of the integration is constant, then we use the integration by part, and definitely if this is constant, so what is the derivative of constant? It will be 0. Similarly, the derivative of constant in the lower limit side also 0. So this 2 will be erased or eliminated if the limit of the integration will be constant. So ultimately we get this rule. So Leibniz rule is the extended form of the DUIS rule number 1, where the limit of integral were constants. Now here, since the limit of the integral are not constant, so we have to use this DUIS rule number 2. Let I of alpha, which is equal to integration of a to a square, integration under the limit a to a square of log of x under with respect to x. Now we have to verify here DUIS rule number 1, rule number 2. Now using DUIS rule or Leibniz rule, we have, so we apply this rule. So derivative of I with respect to a, which is equal to integration of integration limit are a and b. So in place of a it is a, and in place of b it is a square. Then derivative of log of x with respect to a, and whole integration with respect to x, plus f of x alpha is log of x, so replace x by a. So this is what log of upper limit. Upper limit. So what is the value of x over here? Log of x. So x is upper limit a square. So we can write down log of a into a square into derivative of upper limit a square with respect to a minus this one, functional value of the given function log of x at x equal to lower limit is a. So log of a, and the value of x is a. So log of a into derivative of lower limit is what? Lower limit is a. Derivative of a with respect to a. Now let us try to simplify this one. The first thing is, what is the derivative of log of x? So we know that the derivative of log x is 1 upon x, but now here we have to differentiate with respect to a. So What is the derivative of log of ax? It is 1 upon ax. Again, derivative of ax with respect to a is x dx. So integration under the limit a to a square. Derivative of log ax is 1 upon x. Again, derivative of ax with respect to a is x dx plus log of a cube. Log of a cube. Derivative of a square is nothing but 2a minus derivative of a with respect to a is 1 log of a square. Log of a square. Let us again simplify it. Now this x and this x will cancel. So di dA which is equal to 1 upon a. So integration of dx is x under the limit a to a square plus 2a log a to the power 3 minus log a square. Now if we put the upper limit, it is a square minus a upon a plus this will be multiplied to this. So this is 6a 6a log a minus 2 log a. 2 log a. Let us again simplify it. If we take a common over here, so a will cancel, a minus 1 is remaining, plus 6a log a minus 2 log a. This is the value of derivative of I with respect to a, di dA. Now consider IA is equal to integration of log ax under the limit a to a square into 1 dx. Now we want to just evaluate as usual method, or we have to use the integration of, or we have to evaluate this integral as the rule, using the rule of integration only. So now if you want to integrate with this log x, it is not possible, so we have to introduce 1. Now we can apply the integration by part. So this is what first function is 1. What is the integration of 1? It is x. Then log of x under the limit a to a square minus derivative of log x is 1 upon x with respect to x over here. So 1 upon x, again derivative of ax with respect to x. This is nothing but 1 upon ax and into a, and then integration of 1 is x dx. Now this ax and ax will cancel. So we have a square log a cube. If you put the upper limit, a square log a cube minus a log a square minus x, because again integration of dx with respect to x under the limit a to a square is x a to a square. So again we can write down this is 3a square log a minus 2a, this is multiplied to this side, 2a log a minus a square, and minus minus will become plus a. So this is the value of I of a. Now we want to find out the derivative of I with respect to a. So let us differentiate it. Differentiating with respect to a, we have di dA which is equal to, now here this is the product of two functions a square and log a. So a square first function, derivative of log a is 1 upon a plus derivative of a square is 2a into log a minus 2 we can take outside. Again a into log a, so a upon a plus derivative of a is 1 into log a minus derivative of a square is 2a and derivative of a is equal to 1. Let us simplify it once more. This a 1a will cancel. So 3a We can write down 3a. 3 into 2a is 6a log a minus this a will cancel minus 2 minus 2 log a minus 2 log a minus 2a plus 1. It is now it can be written as a 3a minus 2a. 3a minus 2a is what? It is a, then minus 2 plus 1 is minus 1 plus 6a log a minus 2 log a. This is equation number 2. So now if we see the equation number 1, dIdA, which is obtained by using the DUIS rule, the value is a minus 1 plus 6a log a minus 2 log a. Similarly, if we find out the value of dIdA using the as usual method, we are getting the same answer, a minus 1 plus 6a log a minus 2 log a. So hence from 1 and 2, DUIS rule or rule of differentiation under integral sign is verified. Thank you.